One of the problems we're going to face in this class is dealing with numbers that are really big and really small, all in the same sentences sometimes. For instance, if we have a radius of a hydrogen atom, we find the hydrogen atom has a radius of something like 0.0000000000053 of a meter across. Incredibly tiny, but an incredibly common kind of measurement we make in chemistry. Now, we can face this with a number that might be the number of hydrogen atoms in 1 gram. And this is going to be something like 602.000.000.000, and a whole bunch more 0.000.000.000, and another 0.000. And this is the number of hydrogen atoms in 1 gram, approximately. So there you go. So in the space of about 30 seconds, we wrote down numbers that were just massively different from one another. Now, scientific notation gives us a way to write these numbers without going crazy with all these zeros. And in scientific notation, all our numbers are written as essentially x times 10 to the y, and x is almost always a number between 1 and 10, although really between 1 and 9.99999, I suppose. And y is a whole number, so it can be 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. So we wouldn't write it as, 11.3 times 10 to the negative 2.4, but we could write it as something like, 1.8 times 10 to the positive 8, let's say. And in scientific notation, what we have to do, and you've probably seen this before, is we have to move the decimal place to generate the number. So this top number right here, we can move the decimal place 3 times, and 6 times, and 9 times, and 11 times. And when we move it 11 times, we generate the number 5.3. And so in scientific notation, this is 5.3 times 10. And then the number of times we move the decimal place is going to be the y here. And I always remember that y is going to be negative, so minus VE, if the original number is less than 1. And it's going to be positive, the number of movements, if the original number is greater than 1. It seems to make sense to me. So because this number right here is less than 1, it is going to be 10 to the minus 11. So 5.3 times 10 to the minus 11 meters across. Whereas if we look at this number here, notice the decimal place isn't written, but you can guess where it is. We've got to move the decimal 3, 6, 9, 12, 15, 18, 21, and then 22, 23, and that gets us a number 6.02. So we multiply that by 10 to the, the original number is greater than 1. So this is like 602 with 21 zeros after it, so that's definitely greater than 1. So 6.02 times 10 to the 23. And we'll see later on that this is called Avogadro's number, and these are the kind of numbers that we're dealing with in chemistry. So very large, very small. Scientific notation makes it very easy to keep track of these numbers without losing your mind.